Hey guys, welcome back to General Chemistry. We're going to continue on talking about these advanced bonding theories. And today we're going to talk about something called pi and sigma bonds. So sigma bonds are going to be our single bonds. So for sigma bonds, there really can be a plethora of different combinations that can make a sigma bond. So we could have standard S to S orbital overlap. We could have standard P to P overlap. Or we can mix any of the standards with the hybrids. We can mix hybrid with hybrid. So there's going to be a number of different ways that a sigma bond can be created. But really the main thing to remember here is that a sigma bond is going to be our single bonds. A pi bond is going to be our double or our triple bonds. For the pi bonds, there's really only one option for the pi bonds. So the only way to make a pi bond is between unhybridized parallel p orbitals. It's a lot of p's there, big alliteration. So let's break this down a little bit. Unhybridized. So unhybridized means it's just a standard p orbital. So remember the p orbitals are one lobe going up, one lobe coming down. So that was your standard p orbital. And it's going to be parallel. So if I'm looking at, and there's a better picture of this later, but if I'm looking at a standard p orbital that looks like this, parallel would mean that there's another standard p orbital that's running in the exact same direction as the other one. And so where is the overlap going to happen? Well, these are going to reach kind of across this gap or across this chasm, and this is where that overlap is going to happen. So unhybridized means they're just standard p orbitals. Parallel means they're right next to each other, and they're going to reach across and make that double or triple bond. So here's what it looks like kind of in real life. Of course, real life is a little bit messier, but this is an example of this carbon-carbon right here having a single bond. So carbon-carbon has this single bond in the middle, right? We always start with a single bond. And then we see these p orbitals. They kind of look like big balloons here, but we really see these p orbitals reaching across and overlapping with one another. The interaction between the parallel orbitals is not as strong as the other sigma bonds. So sigma bonds are going to be a stronger bond. They're a lot closer. That overlap is a lot greater, where these double bonds and then triple bonds are reaching really far across to overlap with one another. So they're not quite as strong as the other ones. Overlap of two p orbitals is greatest when the orbitals are end to end. So this would be an example of two p orbitals coming together for a sigma bond. This one actually doesn't exist. That's kind of silly. It doesn't exist at all. But the A one does exist. So this would be an example of a sigma bond, kind of an end-to-end overlap. If we're looking at these pi bonds, here we see two p orbitals that are parallel to one another, running in the same direction, and the overlap happens with the side of those lobes. So this is where we see that side-to-side overlap. That's the only way that we can make a double bond or triple bond. And here's just another picture of kind of the same thing. So down at the bottom is our end-to-end overlap. So two p orbitals kind of coming in a head-on collision. The top one is we got two p orbitals that are parallel, running in the same direction, and they reach across. So how am I going to test you on this? How are you going to be assessed on this? Well, you'd be given a molecule such as this one, and I might ask you how many sigma bonds or how many pi bonds are present in this molecule. Okay. So of course, any of the single bonds are going to be sigma bonds. So there's one sigma, there's two sigma. When we look at this double bond, the first bond will always be a sigma bond. So the first bond that forms in any molecule will be a sigma bond. And then if there's an additional bond, let's say this guy at the top, that the additional bond would be a pi bond. So the answer to this one would be 3 sigma bonds and 1 pi bond. And here's what it looks like kind of in real life in 3 dimensions. So in the middle of this molecule, we've got that carbon to oxygen sigma bond. So that first bond is a sigma bond. And then we got this carbon to oxygen pi bond up here. Here's another example. I could ask the same question here. So how many sigma bonds, how many pi bonds? So again, single bonds are easy. Single would be sigma, sigma. Now we've got 3 bonds here. We've got a triple bond. Well, one of them is going to be a sigma bond. And then the other 2 are going to be pi bonds. So the answer to this one would be 3 sigma bonds and 2 pi bonds. That's pretty much it for sigma and pi bonds. I hope you guys found that helpful.